Hello, my name is Crystal Rivera, and welcome to Virtual Labs version 7.0. This will be a brief introduction to the Virtual Labs module within the system. First, the current system provides an interface through eFront which integrates with Moodle that allows students to reserve different types of resources, which include Virtual Labs mentoring and certificate exams. This system also utilizes a combination of VMware, KVM, and Java applets to host the RDP sessions for the labs. There are certain limitations that we wanted to improve upon during this semester. First of all, utilizing Moodle is unnecessary since the eFront learning module system can handle the modular functionality we need. Also, Java applets are becoming outdated in most major browsers like Safari, Chrome, and Firefox, so we would like to find an alternative to hosting the RDP sessions, such as an HTML5 gateway. In addition, rather than using a combination of both KVM and VMware, it was decided for uniformity reasons to convert to just KVM. To touch upon the project management for this module, I will briefly touch upon each sprint and what I was trying to achieve in each sprint. For this first sprint focus was on reviewing framework options and familiarizing myself with the current system. For the second sprint, I began creating an eFront module for Virtual Labs and planned out what UI frameworks I was going to use. I also gave a brief tutorial to the team about jQuery and web development. For Sprint 3, I focused on utilizing eFront to its fullest, such as creating themes for Virtual Labs to match the one set in eFront. I also added a navbar to control appointment options and virtual machine commands. In addition, I created an administrator module called VLabs Admin to initially handle granting and revoking Virtual Labs access for a user type. For Sprint 4, I replaced any locally referenced libraries with the online equivalent. I integrated fully with Guacamole using REST to pass parameters in the URL, establishing the connection. In addition, I migrated the current system's Virtual Labs over to eFront to begin some refactoring of the current system's code. In the last sprint, I finished refactoring any code necessary for the complete functionality, and I also finalized the navbar functionality and the user interface. In addition to that, I fixed quite a few bugs. The next section, I'll touch upon the requirements and the implemented use cases for this module. The implemented stories you see here are the highest priority stories implemented during the semester of development. These cover what I previously summarized in the Gantt chart discussion, so we will move straight on to the use case diagram. This use case diagram illustrates the use cases that have been migrated over from the current system and developed for this release. The following are sequence diagrams for the use case diagram shown in the previous slide. This particular diagram illustrates the add time and remove time for the user appointment. Essentially, the user just enters the number of minutes in the input field, and the application logic takes care of the rest. In a similar fashion, cancel appointment, the user just clicks the eject button, and the application logic takes care of it. For VM controls, the application logic is a bit more complex, but from the user's point of view, all they have to do is press a button. Now in the toolbar, the user has the option to change the resolution of the RDP session. What they do is they choose an option from the drop-down menu in the toolbar, and then the application logic saves and sets the proper resolution and reestablishes the RDP session. Change BPP works in a very similar fashion. Another option that is available to the student is that they can open their RDP session in a new browser window. All they have to do is click on the new tab icon, and a new browser tab will open with that particular RDP session and the saved display settings for that session. Next, I will quickly go through the system design and deployment. For Virtual Labs, the system breaks down into a three-tier architectural design. The top tier is presentation, which contains the user interface and is what the client sees. The middle tier is all the application logic that handles all the dirty work. And at the bottom, we have our data tier, which is persistent data and storage. This is our system deployment diagram that shows the hardware and software requirements for our total virtual lab system. For the client, all they need is a web browser and at least 512 megabytes of RAM. For the presentation server, we need an Apache server. We need an Apache server that supports PHP 5, a MySQL server, and eFront version 3.6 and up. Hardware-wise, we need at least 1 gigabyte of RAM, 40 gigabytes of hard disk, and an Intel Core 2 Duo processor. For software, we need an Access 2 server with Postgres and JDK. For hardware, we need at least 1 gigabyte of RAM and an Intel Core 2 Duo. Now on to persistent data design. From a logical point of view, there are really two main objects that are stored for each user. The first is a schedule object. On a high level, this object consists of a VE instance schedule ID, which is a unique ID to identify the specific appointment. The current date, which is today, for example, the end date, which is the end date for the appointment. Reason and success are just to exemplify the status, and resource type for virtual labs module is virtual lab, which specifies the appointment type. In addition to this object, we also maintain an instance information object that holds the virtual environment information. This object contains an array called kserver. This is the virtual environment's instance of the Kaseya server and its appropriate connection information. An array called vminfo, which holds all the other virtual machine instances and their appropriate connection information, and reason and success for status information. On the basis of security and privacy, there is a predefined set of user types that dictates which are granted VLabs access and which are not. If the user type is not in this list, it defaults to false, aka they don't have access. Each user's virtual lab is scheduled with the unique instance ID that we previously discussed. This is used to load the specific instance. No user can access any other instance or i.e. appointment but their own. Similarly, each virtual machine for the virtual environment has its own unique instance ID to identify the individual machines assigned to that virtual environment. This ensures the isolation of the workspace. The next big section is called detailed design. We are going to go over briefly class and object design. This class diagram briefly introduces the view, model, and controller, aka the three-tier design of virtual labs. We have our tabs interface and our toolbar on the UI, which contain different types of tabs and the VM controls and time controls. And then in the application logic, we have our appointment control functions and our button control functions and our VM command functions and things like that. And in the web service side here, we have different classes that manage the web service requests. This is a state diagram that illustrates the process of time controls. When is ready and we receive a request, we have to figure out whether the request is to add time to the appointment, remove time to the appointment, or cancel the appointment. These then go to the web server, and then the response is sent, and we get routed back to ready. VM controls works in a very similar fashion, except this time we have our various VM control commands. This slide explains on a very high level the algorithm used to implement time controls. Essentially, if the user wants to add or remove time, we grab the amount that they have inputted, and then we send that along with user credentials and the particular unique instance ID to the scheduler, and the appointment is updated accordingly. If it's a cancel appointment, we just send the credentials and the schedule ID, and the calendar scheduler will cancel it and update the database accordingly. For the VM controls, we essentially just grab the command from the button that the user has clicked. We build an object called a VMC object, which is just an object that holds information such as the command that we just grabbed, the instance ID, and the virtual machine name. Once this object is built, we then AJAX with this object's information and the user credential. The receiver then interacts with the web service to send the appropriate command to the virtual machine via command line. Then the call returns and the user interface displays a status message and the virtual machine status is updated accordingly. Now onto verification. For verifying the functionality of the time controls, we have three main test cases. The first is to test adding time to the appointment. We essentially tried adding 60 minutes and checked to see if the timer increased appropriately. When done, the output was as expected. However, if the server happens to be down or crashes during this process, the update will not be successful. Remove time works in a very similar fashion, where instead we decided to decrease by 60 minutes. And again, the output was as expected. However, when the server is down or it crashes, the update was not successful. Now to verify that cancel appointment works as it should, we click the eject button and we see whether or not we are redirected to the powered by screen. The output was as expected, and when we tried to log back in again, a new appointment was scheduled for us. Testing the virtual machine controls was synonymous for each type of command. To verify that these command buttons worked, we simply went one by one and verified that the status message displayed was correct, and when appropriate, the RDP session was restored. Actual output was 100% as expected. Now on to a brief demonstration of the Virtual Labs module.
Alright, just a quick demo of what Virtual Labs module is like. So when the user logs in, the first thing they see is this network diagram. What this network diagram displays is all the virtual machines in this virtual environment. Now, if we hover over one of these virtual machines, we can see the various connection information for this particular machine. If we wanted the connection information in a table format, we just go to the Connection Info tab, and neatly laid out is every machine and the connection information. Now these tabs are the RDP session tabs. Each one hosts the relevant machine ready for the student to tinker with. They don't have to log in or anything. Now up on the top we have our virtual machine controls, where the student can either shut it down or suspend it or refresh it, things like that. Currently the refresh all has not been fully implemented, so this will not work properly. In addition to that, on the toolbar there is a resolution and a color depth drop-down selects. What these do is the student can choose the display settings they would like for their RDP session. Up in this corner of the tab, we have an Open RDP Session in a New Tab button. What this does, it just opens the RDP session in a new browser tab with the same display settings that the student had previously saved. And it would disconnect you from this one. Now, these are all identical. In reference to appointment controls, our timer is right here. This is how much time is left in the appointment. And these buttons are what control the appointment. So if you wanted to add time, you would simply add the amount of minutes you would like, which is defaulted to 5, and you click the plus button. If you want to remove, you do the same thing but click the minus button. And if you wanted to cancel, you click the eject button and you will be redirected to the powered by screen. Thank you very much for watching this introduction.